It rolled into broken landscapes where roads were more theory than fact, forcing its wheels across ground that seemed determined to swallow anything with an engine. In monsoon rain and choking dust, the M35 kept moving because supplies had to reach people who were depending on them, not because the fight demanded drama. Its straight-six power plant pushed a steady pulse through the chassis, giving crews something dependable in conditions that rarely offered comfort or predictability. It didn't arrive to make headlines. It arrived so others could simply keep going. And wherever it appeared, work that couldn't wait finally had a way through. The years after the Second World War left the United States with a simple but crippling logistical problem. Armies still needed a rugged, medium-weight truck, yet the wartime fleets were old, mismatched, and wearing out faster than depots could repair them. Vehicles from the 1930s and early 1940s struggled under new post-war realities, especially when confronted with heavier loads, expanding commitments overseas, and the changing expectations of modern mechanized forces. Commanders needed a single standardized truck that could survive mud, snow, steep grades, and primitive roads without requiring a convoy of mechanics just to keep it breathing. The G508 and G509 wartime trucks had proven their worth, but they were never expected to power the first decade of the Cold War. Their brakes faded on long descents, their engines protested when overburdened, and their suspension systems were too fragile for the expanding network of rough supply routes forming across Europe and Asia. What the US Army lacked was a medium cargo hauler that combined the toughness of a wartime workhorse with the simplicity required for global serviceability. Enter the concept behind what would later become the M35, a 2.5-ton, 6x6 standardized truck family with a multi-fuel option, simple driveline architecture, and a frame strong enough to carry everything from ammunition pallets to radio shelters. Engineers wanted a machine that didn't depend on perfect fuel, perfect weather, or perfect roads, because such luxuries rarely appeared where American logistics were needed most. Its proposed design focused on three critical improvements. First came upgraded axles capable of withstanding the twisting forces of steep climbs and uneven surfaces. Next was a new chassis layout, built to flex just enough to avoid cracking under constant strain while still supporting the weight of cargo, crew, and kit. Finally, a larger, more serviceable engine bay meant field mechanics could perform repairs without fighting the truck for access. By the late 1940s, every branch of the American military understood that its global commitments required a fresh approach to transport, something beyond patchwork fleets and overworked engines. It was the era when logistics stopped pretending to be tidy and demanded equipment built for the world as it actually was. And amid this growing urgency, the shape of the future M35 began to take form. The vision for the M35 series didn't emerge from a single drawing board, but from a growing consensus among engineers and logisticians who had lived through the supply chaos of global war. They wanted a truck that solved, once and for all, the recurring problems of mixed fleets, mismatched parts, and wildly inconsistent performance across theaters. The American doctrine of the late 1940s emphasized mobility above all else, especially as new alliances and overseas commitments stretched supply lines into regions that barely had roads at all. REO Motor Car Company became the nucleus of this new thinking, tasked with creating a truck that was powerful yet serviceable, robust yet uncomplicated. Their proposal emphasized modularity long before the term became fashionable. A common chassis could support cargo bodies, troop seats, van shelters, tankers, wreckers, and communications platforms, reducing the logistical nightmare of stocking incompatible components. The design team focused on three core principles. First, fuel flexibility. The multi-fuel concept would allow future variants to run on diesel, gasoline, jet fuel, and improvised blends, giving field units resilience in regions where fuel quality varied from poor to questionable. Second, driveline simplicity. A mechanically driven 6x6 layout with two-speed transfer case provided predictable traction, easy diagnosis, and straightforward repair, even when the nearest workshop was a tarp on the side of a road. Third, structural endurance. A ladder frame built from cold-formed steel sections allowed the truck to twist across uneven terrain without fracturing, a problem that had plagued earlier wartime designs. There were debates, of course. Some officers insisted the proposed truck was too large for narrow European roads, while others argued it wasn't large enough for Pacific supply routes. Even the engine type became a contested topic, with various factions pushing for petrol, diesel, or the emerging multi-fuel concept. Yet, as the Cold War expanded, it became clear that any new vehicle had to be versatile rather than perfect, adaptable rather than elegant. Despite the arguments, the guiding philosophy held firm. When a design survives a committee, you know either it's genuinely good or everyone's too tired to keep disagreeing. And as the final blueprints emerged, the shape of the M35 reflected a machine intended to serve not one battlefield, but an entire era. The birth of the M35 series began in a manufacturing landscape still shifting from wartime urgency to Cold War pragmatism. Factories that once stamped out tanks and aircraft now learned to produce something quieter but no less essential, a truck engineered to work harder than the roads it travelled. At REO's production lines, the M35's chassis rails arrived as cold-formed steel lengths, each piece treated with a precision that wartime mass production rarely afforded. Workers aligned them within jigs that locked every angle, ensuring the frame could flex without failing when the terrain turned unpleasant. Component machining followed a strict hierarchy. Axle housings were cast thick enough to survive repeated shock loads from rocks, ditches, and careless drivers. Gear sets were cut with tolerances chosen to prevent heat build-up during long climbs, especially when the truck carried more than the polite 2.5-ton rating suggested. Even the wheel hubs, simple at a glance, were built with manually serviceable bearings so field crews could strip, clean, and repack them without a workshop in sight. The engine blocks, initially petrol-powered and later multi-fuel, were assembled with oversized cooling channels to prevent overheating during low-gear slogging. Carburetors, injectors, and filters were arranged to be reached from above, below, or through the side if necessary, because the truck's designers understood that maintenance rarely happened in comfortable environments. Assembly lines operated in a rhythm that felt almost industrial musical. Frames advanced on rollers, receiving axles, springs, tanks, and wiring harnesses as teams moved with practiced efficiency. The result was a chassis that looked deceptively simple, yet hid layers of engineering meant to withstand decades of punishment. Quality control teams were merciless. They torque-checked every structural bolt, pressure-tested brake systems, and inspected welds with tools designed to reveal the slightest imperfection. Even the paint served a purpose, offering corrosion resistance that helped the truck survive climates ranging from Arctic cold to island humidity. The M35's construction philosophy reflected a shift in American thinking. Dependable engineering wasn't a luxury, but the backbone of global operations. Its parts weren't assembled so much as persuaded into forming a truck that planned to outlive the arguments that created it. And once production ramped up, the M35 family began rolling from factories with the quiet confidence of a machine built to endure whatever came next. The proving grounds did not welcome the M35 with kindness. They offered heat that warped the air, mud that swallowed boots whole, and wind that scattered sand across every exposed bearing. It was precisely the sort of environment the Army demanded, because a truck meant for global service needed to survive conditions that didn't respect good intentions. Engineers drove the prototype across ruts deep enough to challenge its ground clearance, while evaluators stood beside clipboards, hoping the suspension wouldn't simply give up the moment it met reality. Early runs revealed critical behavior. The twin reduction axles distributed torque smoothly across the driveline, even when one wheel fought for traction on loose soil. The ladder frame twisted under stress, but returned to shape without complaint, which mattered immensely when traversing uneven hillsides where lesser trucks simply fractured. Brakes were stressed during downhill tests, their drums heating to uncomfortable temperatures as inspectors logged every quirk in pedal feel. The prototype steering system faced its own torment. Tight turns over loose gravel exposed how the front differential engaged under load, forcing evaluators to adjust caster angles until the truck tracked predictably. Exhaust manifolds were monitored for heat soak, and temperature probes recorded how air moved through the engine bay when the truck crawled in low gear. Surge tanks, fuel pumps and filters were checked after every run to determine whether dust intrusion would become a recurring enemy. Crew reactions formed another layer of testing. Drivers learned the truck's rhythm quickly, long clutch travel, deliberate gear selection, and the unmistakable growl of a straight-six engine settling into its workload. The gearbox demanded respect rather than speed, reminding test staff that this was a machine built for persistence, not theatrics. Paperwork became as punishing as the terrain. Every shudder, squeak and temperature spike forced new notes, revisions, and small but important improvements. Transfer case mounts were reinforced, radiator shrouds reshaped, and wiring looms routed to avoid wear points. Through all of it, the M35 displayed an unpolished honesty. It behaved like a machine that had absolutely no interest in impressing anyone, only in proving it could survive the sort of punishment no rational person would volunteer for. And by the time testing concluded, the truck had shown it was not fragile, not delicate, and, most importantly, not going to quit when the landscape tried to erase it. When the M35 finally rolled into real operations, it did not enter with fanfare, but with the quiet urgency of a machine expected to perform without excuses. In regions where infrastructure shifted from rough to nearly theoretical, the truck proved its worth by simply doing the work others struggled to complete. Humanitarian convoys, patrol resupply, engineering detachments, and peacekeeping forces all discovered that the M35's true strength lay not in glamour, but in an almost stubborn consistency. Field reports highlighted key breakthroughs. The multi-fuel engine earned early respect by running on whatever liquid vaguely resembled fuel, a trait invaluable in remote deployments where supply chains faded into uncertainty. The two-speed transfer case allowed crews to shift seamlessly between long-distance travel and slow, controlled crawling over uneven ground, giving the truck a versatility that other medium platforms lacked. Maintenance teams reported that the truck's open-engine layout reduced servicing times dramatically, allowing roadside repairs that would have sidelined more complex vehicles. Operational success became especially clear during prolonged deployments in rough terrain. Its suspension, built around longitudinal leaf springs, delivered a balance between load stability and off-road compliance, enabling the truck to navigate slopes and ditches without placing intolerable strain on its frame. Cargo units appreciated the steel bed's resistance to weather and impact, and its fold-down sides simplified loading and unloading under time pressure. Even communications detachments praised the M35's electrical robustness, noting how radio shelters mounted on its chassis endured vibration and temperature variations without frequent recalibration. But the real breakthrough was logistical. Standardization across units meant spare parts, training, and repairs were no longer a guessing game. Drivers could move between variants without relearning fundamental controls, and mechanics could transition across the fleet with confidence. The truck's predictable behavior reduced mission delays, allowing operations to be planned with fewer contingencies built around vehicle failure. Its limitations did emerge. Weight distribution on steep inclines required careful throttle control, and the truck was undeniably noisy at higher speeds. Yet these weaknesses were considered manageable compared to the reliability gains it delivered across theatres. Through all of this, the M35 established itself not through spectacle, but through endurance. It earned trust the slow way, by refusing to create drama even when the landscape did its very best to provide some. And with every successful mission, commanders realized the truck was no longer an experiment, but an indispensable asset. The M35's true influence did not lie solely in its performance on rough tracks or its ability to move supplies through unpredictable terrain. Its real, often overlooked consequence was how it reshaped the economics, logistics, and expectations of large-scale operations across multiple continents. Nations that adopted it, whether through direct procurement, surplus transfers, or alliance programs, found themselves inheriting not just a truck, but an entire logistical philosophy built around interchangeability and durability. Economically, the M35 created an unexpected ripple. By standardizing so many components across variants, it allowed smaller militaries and civil agencies to maintain functional fleets without investing in vast maintenance infrastructures. Workshops that previously required specialized tools and proprietary equipment could now service the truck with simple spanners, open work bays, and practical know-how. This democratized mobility in regions where transport capability had long been a limiting factor in development, administration, and humanitarian response. Politically, the truck became a quiet instrument of influence. Surplus M35s appeared in post-conflict zones, disaster areas, and along remote borders where roads were more aspiration than asset. Their presence often enabled governments to reach communities that had been effectively isolated by geography. This expanded state capacity in subtle but measurable ways, influencing everything from census efforts to public health distribution networks. As a result, the M35's availability occasionally shifted the balance of local authority, not through force, but through newfound access. Operational doctrine absorbed the truck's characteristics as well. Commanders began planning with the assumption that ground transport could push farther than before, turning previously marginal routes into workable supply arteries. Communications units exploited its stable electrical platform to run early mobile command posts, while engineers used its load capacity to transport bridging materials into places where fixed infrastructure had failed. This adaptability blurred the lines between military, civil, and emergency use in ways no committee had originally anticipated. Perhaps the most significant hidden effect was cultural. In many organizations, the M35 quietly raised the expectation of what standard equipment should endure. Vehicles that failed to match its durability were scrutinized more harshly, and procurement officers increasingly framed new requirements around its proven behaviors. It set a bar so uncomfortably high that newer designs sometimes felt like they were being compared to a piece of machinery that simply didn't know how to age properly. And long after conflicts shifted and priorities evolved, the consequences of adopting the M35 continued to ripple through planning rooms, maintenance depots, and budget sheets across the world. By the time newer generations of military vehicles emerged, The M35 had already entrenched itself as more than a transport platform. It had become a reference point. Its long service across continents created an unusual legacy. Engineers designing replacements had to respect a machine whose core strengths were almost embarrassingly practical. The M35 didn't rely on electronics or delicate hydraulics, so its successors faced the unenviable task of matching its durability while embracing the growing complexity of modern logistics. Across the United States, surplus M35s spread into civilian life, serving fire departments, forestry services, construction crews, and search and rescue teams. Rural counties valued the truck not for its nostalgia, but for its ability to navigate washed-out roads and steep backcountry tracks where commercial vehicles hesitated. Its payload, torque delivery, and straightforward maintenance meant it could be repurposed endlessly, from water tankers to brush trucks, flood response vehicles, and mobile workshops. Meanwhile, military historians noted how the M35 influenced tactical thinking. Decades of field use demonstrated that mobility wasn't simply about speed, it was about dependability under pressure. Units planned operations around the assumption that if an M35 was on the manifest, cargo would arrive even if the route deteriorated halfway through. This reliability shaped doctrine across NATO allies, many of whom adopted the truck or developed derivatives inspired by its layout. Restoration communities added a unique layer to its legacy. Enthusiasts found that the truck's mechanical openness made it an ideal candidate for preservation, modification, and educational work. Museums and private collectors appreciated its structure not because it was rare, but because it represented an era when engineering favored accessibility, robustness, and clear mechanical logic. In workshops and showgrounds, the M35 continued teaching new generations how drivetrains, transfer cases, and mechanical injection systems operate in the real world. Perhaps the most striking aspect of the M35's legacy is how many of its principles carried forward into modern transport design. Modular chassis architecture, simplified service access, and drivetrain resilience all appear in vehicles far more advanced than anything imagined in the late 1940s. The truck's longevity effectively forced designers to prioritize systems that could survive hard use over long periods without demanding excessive maintenance. The M35 remains a machine whose influence stretches far beyond its expected lifespan. It left engineers with the awkward realization that sometimes the simplest design is the one that refuses to step quietly into history. And even today, its fingerprints can be seen on countless vehicles that followed its path across roads, tracks, and landscapes, shaped more by need than convenience. The M35's story concludes not with ceremony, but with a quieter reflection on what it represented. A bridge between eras when logistics began stretching across continents, climates, and political landscapes that shifted with remarkable speed. In the decades after its introduction, the truck moved through conflicts and crises without demanding attention. It simply existed wherever necessity pushed it. That constancy forms the final lens through which its history is best understood. The truck's long silhouette, canvas top taut, engine muttering beneath a wide hood, became a familiar sight from rainforests to deserts. In each environment, crews discovered the same practical truth. The M35 did not make their jobs easier, but it made them possible. Its axles, transfer case, and frame carried not just cargo, but the expectation that progress could continue even when infrastructure faltered. That reliability shaped how planners approached remote operations in the latter half of the 20th century. Technically, the truck's endurance demonstrates something else too. Engineering success isn't always tied to radical innovation. Often it emerges from a set of thoughtful decisions executed well and maintained consistently. The M35's powertrain, suspension layout, and modular chassis never claimed to be revolutionary. Instead, they embodied a design philosophy that favored repairability, predictability, and structural honesty, qualities that modern equipment sometimes struggles to replicate as electronic systems grow increasingly elaborate. This endurance invites a broader reflection on machinery itself. Vehicles designed today must contend with automation, emissions control, network integration, and advanced materials. Yet, the M35's continued relevance in civilian fleets and specialist organizations shows that there is still value in engineering that prioritizes mechanical transparency. It reminds us that a tool's effectiveness often depends on the people who maintain it, not just on the sophistication of its components. Its real legacy, then, is this: the truck served as a foundation on which more complex systems could rely, establishing a standard for practicality during decades when global operations expanded far beyond the assumptions of earlier conflicts. It stands as proof that endurance isn't always loud. It can be a quiet refusal to fail in the face of landscapes that would prefer otherwise. And in that quiet persistence, the M35 secured its place as one of the most influential logistics machines of the modern age.